going to now deal with the diode. Okay, so let's talk briefly about the diode, this PN junction. Okay, so we talked a little bit about it when we forward bias and when we reverse bias it, right? So that is the P and N. Okay, the symbol for this, right, is looks like that. Okay, the symbol for the diode looks like that. So the P side is the flat side, and then the N side is the pointed side. And then since we know that when it's forward bias, current flows in this direction, you know that current can only flow in the diode in this direction, and current cannot flow in the opposite direction. Okay, so this is the PN, which is our diode. Okay, for the diode to be forward bias, for the current to flow when we forward bias, we said that we have to overcome the built-in potential, and that VBI is normally in the range of 0.5 to 0.8, right? Approximately 0.7. So when you have enough voltage applied, right, when you have enough voltage applied, which is greater than the VBI, as soon as you overcome the VBI, now you can flow current through the diode. And this current is going to be controlled by the external resistance you have in the diode, how much resistance you have. If you don't have too much resistance in the external diode or the external circuit, too much current will flow that you might end up burning the diode. So then you are going to smell some stuff if you're in the lab, okay? And the students burn a lot of louds, right? Especially if you don't put in the right current. You flow too much, yeah, you can flow current, but if the current is too much and the power is more than the power that the diode can handle, is going to burn it out. Okay, so that is what we are seeing over here, right? That is a current characteristics. So first you have to overcome the built-in potential, then after that, and then you can flow current. And there is a slope to it, a small slope, right? Very small slope. And because this is voltage and this is current, that slope will give you resistance, but it is very, very small, because if you see R, V is equal to I times R, right? Therefore, R is equal to V over what? I. So you see the V side is very small if I make this, okay, and then the I side is very big. Therefore, this resistance is going to be very small. We call the forward resistance. So there's a small forward resistance for the diode, but it's very small, you know, sometimes 10 ohms, sometimes even less than 10 ohms, but they are very small. So the actual representation of the diode, you know, normally you can represent it by a small resistance. Okay, let's go ahead and erase this one here. So that is the forward, that is when it's forward bias. On the reverse bias, that is when you switch this the polarity of this voltage here. So when you switch the polarity, of this voltage over here, right, now you have reverse bias it. In the reverse bias, no current will flow. When you reverse bias it and the voltage becomes too big in the reverse bias, you can get to a point where the diode will break down, okay, and it gets destroyed, right? It means it gets destroyed. Now there is another diode which is actually made to work in the reverse bias, in the breakdown stage, and this is the Zener diode. So the Zener diode is specifically made so when it goes to the breakdown, it does not get destroyed. So it is doped, the amount of doping they use, and then the thickness of the channel, right, is all made in such a way that this diode can be put in the reverse, can go into the breakdown, and you can operate this diode while it is in breakdown. Now, yes, it can withhold some amount of current while in breakdown. So if you exceed that current, you might damage it. But while you are within the limit of the current when it is in the breakdown, it's going to work very fine. And that is the operation of the Zener diode, right? That is the operation of the Zener diode. If the diode is not fabricated to work in the breakdown and you force it to go into the breakdown, then it's going to get destroyed. Okay, so that's what I want to mention over there. So that is basically how the diode works. So if you look at it, it has three main regions, right? The forward bias, where you need to overcome something before it will turn on, right? So even in the forward bias, you have to overcome the VBI. The reverse bias, it will be off, right? It's going to be off until it gets to the breakdown, and then if it is made to operate in the breakdown, then it will be operating the breakdown. And then if it is not made to operate in the breakdown, then the diode will be destroyed.